Hello, Mr. Okay, let's start. Hello, Mr. Hule. So, welcome you to join a mock interview with Google. Okay, could you introduce a bit about yourself?
Yeah, hey, I'm Vũ. So I have around 5 years experience, and I have working for several companies in US. My first company Walmart, and now I'm working for the Oracle right now in the Oracle Cloud. Currently, I'm working on a security platform. So that is it is the centralized for all the security problem in cloud will be in the centralized in the one place, and then all the team in the Oracle will be go there and fix all the security problem. So our team will be impact like more than 400 team internet in the Oracle, and I'm responsible for deploying the service and implement the like backend high scalable system to serve all the team in the Oracle.
Yeah.
Yep. I focus mostly on the backend right now because I want to become the architect in the future. But yeah.
Okay, sorry. Okay. Today I'll give you a question, algorithm question. And so
yes, sure. Thanks so much.
Let's jump into the question. I'll give you a string, and
okay.
yeah, your task is to find the longest substring, which is a palindrome. You understand?
Longest substring. Okay. So
yeah.
if you have a question, could you type question and then you can give me example? Or or I can type, it doesn't matter.
Yeah. Okay. Okay, you can type. I'll give you a string. Let's find the longest palindromic substring, and you can print it out or return. Return it.
Okay, let me type out. So make sure like I'm on track. I focus on the question. Okay, we give the string like the input.
Give you a string. Yeah.
Input like string h.
Okay.
String h, and then what we do like we find the longest.
Palindromic substring. Yeah.
Okay. And then we return that string, right? Return that string.
Yeah. Return it.
Okay. So let me get the example. Example like we have a string like B C something like an A B B B A, right?
Yeah.
So mean the longest palindrome should be like A B B A. Is that correct?
With long 5. Yeah, it's correct.
Yeah. So we have like or B like result, okay, or like result. So we should have written something like A B B B A, right?
Yeah, correct.
Okay. Let me think how we can solve this problem. So for example, like string, and some my string is empty or string. What is the length of string?
Suppose as string cannot be empty. Okay.
Cannot be empty, and the length. I assume the length of string may be very long, right?
Yeah, very long. Yeah.
Okay. So good. Okay, how we can do that? Like find longest. So first one, like longest palindrome. That means like when we travel from left to right of a string, and then when we travel from right to left of a string, so we got the same string, right?
Yeah, correct.
Okay, and then how to find the longest how to find the palindrome? I know, but like in the string we have a lot. How we can find the longest palindrome? Okay, what is the easy way we can do? Like we can find all the substring, right, in the string, in the original string. Like basically the original string only the substring of them, and then we find all the substring in the original string, and then what we can do, like we travel through all the substring, and then we can use the like last variable to keep track like what is the maximum length, and if that substring is a palindrome, and then we compare one by one, and we return the string we want. So if we do like that, so the time complexity will be like O n square, right? Because because we travel through string, and from every point we need to go to find what is the substring over there. And then maybe that's I want to confirm with you, maybe that's one is not like optimized solution. So I mean Yeah, right. So I think like if the
could you
length of
could you try down time velocity and space velocity for your algorithm?
Yeah, so for example, like if we have like first one, you start from C, and then you find like CH, CD. First one, right, you have to start from C, and then you find CH, and then you find CHD, and then you find CHDH. So if you, that means you start from C, and then the rest of substring you travel consecutive into the N. So that means the time complexity, and then you start with the next character in the string like H, and then you start with the HD or something like this, travel into the N, and then you have like, then you find the ON square substring, right? And then you travel ON square substring, and you find palindrome. So yeah, and then that's one. It doesn't make sense. Because you travel ON square. So and then you have a like algorithm to find a palindrome of that one. So the time complexity should be greater than ON square, right?
Yeah, that's correct.
Yep. Yeah. So it doesn't look good because the string maybe look very long, and then we think like right. But when I do that, I have an idea, like for example, we have I and J in the substring, right? For example, if we pick up one index in the substring and the second index in the substring, so for example, you have a range from I and J, and then so how we fastly find the palindrome. That means how we can implementation, right? Before we have a ON square, right? That means to find all the substring, right? And then we go through every substring. So that means we go through ON square, and then we find like, oh, hey, this substring is a palindrome or not. So that's when maybe take time. So that means if we travel ON square to find all the substring, and then if we go every of them, and we immediately to improve like, hey, this substring we can find the substring from I and J into the O1. So because we know what is starting point of the substring, right, and ending point of the substring. So if we can do that's one O1, so we can decrease the time complexity right now will become ON square. So that means I think the problem we need to solve right now, like if we have like I and J, so how we know that is the palindrome? Is that make sense?
Yeah.
So and then I think like time complexity around ON square. That's what you're looking for?
Yeah, ON square for runtime is okay. But space?
Space, like you travel and then you have, I think that like space also ON square.
Okay. Could you implement it? So I think
but
it's good enough.
No, but I think I that idea, but let me think like how I can from I and J I can implement that. I think about like look at this example, A B B A, right?
Okay.
A B B A. For example, I assume like A B B B A. Sorry, I assume like right now like I will be equal. So for example, I'm start from A equal for 0, right? A equal for 0, and J right now will be 0, 1, 2, 3, 0, 1, 2, 3, 4. So, but you can see like I call A1 equal for 1, and you call J1 equal for 3, right? But if you have already know I1, J1, like the range 1 and 3, we have a palindrome. Like for example, I assume like BBB, I know, hey, I know B1 from 3 will be palindrome. So if you have like 2 more characters from the beginning and the end of that will be AA, right? But you know the middle have already palindrome. So I know, hey, I know like the end and the beginning of that string will be palindrome. So that means that whole string will be palindrome, right? So that means I look like we reduce the result from the previous computation, and then we build our result right now. So that means ABBA should be palindrome because BBB have already palindrome. We calculate that before by somehow we calculate that before. And then we can, So I think that means before we find all the substring, so we need to do somehow to know like from I and J how we pairing ROM. So I and J pairing ROM, so because the relationship between A and J, so that means I can have a relationship with multiple J, right? And J, the opposite side, J can have a relationship with multiple I. So I think I will build like the matrix, and then I will like matrix I and J with I equal for length of string and J also equal for length of string, and with every I and J, I will buy like I will check like, hey, if I and J, the range of that one is a pairing ROM. If that one we pairing ROM, mean I plus one and J plus one have already pairing ROM, right? And then I know like, hey, A and J will be pairing ROM. But that means I need to calculate I plus one and J minus one first. That means I will need to go from like smaller thing first. Like I'm thinking about like I will start from like I minus one. I mean, I will start from a smaller chunk before I go to the big chunk. So how I can do that? For example, how about if I start from like if I run from h dot len minus one, and I could be greater than equal for 0, and I minus. And I also have a like J also do something like x not len. Maybe forgot the kernel K right now with that's but that basically the idea. So greater than 0 and J minus. Okay, so that means in this case for sure I will calculate like I equal 1 and J equal 4 3 like in this example, right? Because I will be start from end of len, like len will be now will be equal for 5, right? 0 1 2 3. I take string a b b a, and I have a a1 equal for 5, and then it will go from 5 into the 0, 4 equal to 0. So that means I1 for sure will be before that. And let me see. I maybe have something, I do something wrong here. I think like I'm thinking different.
It is wrong.
J should be like this, and then J should be run from the wait a second. J should be run from like I plus 1.
Yeah, it's correct. Yeah, for every point I, so you can expand to the left and to the right. It's correct. Yeah.
J less than I plus J equal for I plus 1. J less than h dot len and J plus something like that.
Yeah.
Did that make sense?
Yeah, it makes sense.
All right, so if I find the I and J like pairing ROM, so for sure like travel through matrix like that, time complexity will be ON squared. And I also have a matrix, right? So space complexity ON squared, and then I travel through the all the substring in the H, also ON squared. And then I keep the maximum. So like time complexity will be O2N squared will be, that means ON squared, and space complexity will be ON squared.
Yeah, okay. Let's implement it. So
okay,
I like your idea. Okay.
Sure.
Okay.
Okay, could I implement by Java? Does it matter?
Okay.
Okay, doesn't matter, right? Java, I implement by Java.
Java, okay.
Okay, sorry. Longit pairing ROM, so longit pairing ROM string. String, so we have a string H. Yeah, first one I will implement like I will have a matrix, right? So I can assume like Boolean, like me I and J. We have we have gas equal for, oh my god, new Boolean sh not len. Okay. Right. So for in I equal for 0, I less than h dot len. J equal for, no, sorry. I equal for minus 1. I greater than 0 and I minus. method for j equal for I plus 1, j less than 8 dot length, and j plus plus. Okay, and then I have a cast at I and j will be equal for if, right? I and j will be equal for empty. If for we have a like if like string dot get if h dot get I will be like equal for h dot get at j.
Yeah.
Oh. Sorry, the format in work is difficult. So we have a like cast at I and j equal for cast at I minus I plus 1 and j minus 1. Maybe have some bug here. The reason because there may be like I minus 1 like will be different, will be like outbound, right? So
yeah,
let how to do that. So that means we have like j plus 4.
maybe some bug. So
yeah, sure, no problem. I will in
sure.
If so we have like if basically if I equal for j, so we can have like okay.
Yeah, it can be. It's I is not equal to j because j starts with the value of I plus 1. So
I plus 1 will be if less than equal for j minus 1. So we can have that.
Oh.
L, we have a cast at I and j equal for 2. Right?
Yeah.
Okay. So if I is so we mean cat equal for 4, and then we can move forward.
Yeah.
Okay. So
the default value in cast is 4, right?
Yeah, right.
Okay.
Yeah. Because that is primitive value. So primitive value only have a 2 value because the poolant is not in the object right now, so they don't have a like none value.
Yeah.
So we have a h not length, and we have a like I plus plus. Okay. Say equal for like I and j less than h dot length. Say plus plus. We have a like maximum equal for like 0.
Yeah.
Maximum at least equal 1 because the string is not empty.
Yeah.
So we have a like max equal for maximum dot max between max, and we have a cast at I and j. Then we
get ij just contain the value of boolean value, right? So it's not integer.
Yeah, sorry. Integer if I and j will be math. So my bad. If cat I and j will be like name. If we have a like mass will be less than j minus I will be sorry.
I think I will remind you return that string. Yeah.
I see. I see that. I see that.
Yeah.
I mean, math equal for j minus I will be plus 1, and we have a string equal for result equal for like empty or empty from beginning. Or I can have a like string equal h dot get 0.
Yeah.
Like we can have a like this plus y to get 0.
Yeah.
And then we have a result equal for I don't want to substring multiple times, right? You know, so that means I have a like 2 value more for starting point and ending point.
Yeah.
Yeah.
Starting point
for like 0 and equal for 0.
Yeah.
So I will have a like star equal for like star equal 0 and equal 1 for smash for them. Because at least we also have a like 1 character, right? Star equal for I and equal for like j plus 1. Okay, and then we return for result. We return for 8 dot substring from star and n. Yeah. Yeah, it mentioned, but for like Google, we need to testing in all case, right? So let me testing by hand. So I mean, we code done, it not mean we done. We need to test the file.
I also will give another test case for you. Just contain early string, ABC. S equal to ABC.
ABC?
Yeah.
Okay. If ABC, okay. All right. Let me bring here too easy to close in the top because my main method almost in top. So okay, if we have an ABC, so now we have the cast at like 3 and 3, right? So that means we have a like gap like this, right? Fonts.
I think you could find a book with this that case.
Yeah, sure.
Yeah.
Okay. All right. So for example, like we have an h dot length equal 1 greater than 0. So that means we start from I right here and we start from j equal. Okay, I can see I have a problem right here. Like I can start from I j right here instead for j plus 1 because maybe cat at j will be not alpha, right? Right, the first one. So I can see like I have a j start also from I right here, right? So if I have like, so that means I right now equal for 2, right? And j also will be equal for what? J is also equal for 2, right?
Yeah.
Okay, I equal for 2 and j equal for j also equal for 2.
True.
Yeah, j also equal for 2. So for sure, like I will have a like I equal for j and j I plus 1. So this one become 2, right?
Yeah.
And then j cannot moving more. So that is problem, right? Because like I equal for j, so that means wait a second. I want like I equal for j. Yeah, for sure, like that one should not moving more. So this one equal for true like here, right?
It's correct.
Okay.
Of course.
And j become for like 1, right?
Yeah.
And j will be run from 1 to like 2,
True.
right? Okay, I become for 1. So you have like b, and then I plus 1 less than or equal for j minus 1. So that means I plus 1 must be greater than 0. So that means cat at here will be equal for 2, right?
Yeah.
And then I have like b and c. So b and c. So you have like I can see I have a bug right here. Oh no. I and j doesn't. So this one still free for 2, 4. And then I move back into I equal for 0 right now, and j will be run from 0 to 2.
Yeah.
And then I have a like j equal for 2. So this one will be equal for 2 and 1. So this means 4, right?
Yeah.
Okay. So I have to do like this, and then okay, now I will travel through the h dot length, and I can see like, hey, first one I travel through like so I remove this one. I equal for like 0, and j will be equal for 0 right now. So mean I will have like yeah, cat at 0 and 0 it will be equal for 2, right? And I have a math equal for 1, so 0 minus for 0 plus 1 also cannot be greater than math, right? So that means the start and end of the substring is not changed, right? And then I move to j equal for 1. So that means I have a and b cat equal for 4, so I can continue. So j equal for 2. So that means I have like 0 to 2, 0 to 2, right? Phone, right? And then I can skip and then continue to do like that. I have like 1 and 1 0 will be 1 1, sorry, 1 1 will be 2, but it's not will be greater than math because math original will be 1 and 2 will be phones. And then we move to r equal for 2, and then j will be equal for 2, and then I have a 2 2, but still greater than math. So that means when we have an n, so we have a start will be equal for like 0 and n equal for 1. Yeah. And then we can return substring from start and end. So this should be A.
Yeah. So it's good. It's enough.
Okay. Yeah.
Okay. Your course look good. So, but however, I will have for another follow up for you. So, okay. So now you're using space with n square, right? So can you reduce it to constant? Yes, for space. Constant space. Yeah, constant.
Oh.
Yeah.
Constant space. Okay. Okay. How we can reduce the constant?
Yeah.
So if we want to reduce constant, so that means from I and j, by somehow we know like that when.
Maybe.
Yeah. Oh, so I have a question. If we reduce the space to constant, so that means if we reduce space to constant, so mean we still have like let me think a little bit. If we reduce space by constant, the time complexity is still on square, right?
Of course. Yeah, time complexity just reduce the space. Yeah. Just reduce space. So yeah, I will give you a hint. So maybe.
Yeah, go ahead.
Okay.
Go ahead.
Okay. Every palindromic string, right? We have a middle point. So for example, A, B, A. So the middle point is B, right?
Yeah.
And for the palindromic substring A, the middle point is AA, right? So let's try to go to the left and go to the right for every middle point, and then you can find long list palindromic substring.
Yeah. Sorry, could you repeat? I still did not get that.
Okay. Every substring will have a middle point.
Yeah, right. Yeah. That's correct.
Yeah, A, B, A. So the middle point is B. For the string A, B, B, A, right?
A, B, B, A. Okay.
Yeah, the middle point is B, B.
Right, middle point B, B.
Yeah, middle point can contain one character or two characters. Yeah.
Right.
Depend on length. So okay, for every middle point, we can use two pointer. For example, go to the left and go to the right. So let's check.
Okay.
Check every case. So.
Okay. Let me think about that. All right. How can do that? Like for example, like you have for like you have a string and then you have a middle point. I mean, you start from some middle point, right? So for example, like you start from some middle point, and then you expand until you got. But how you expand? If you expand, if you see like from the middle point, if the left of the middle point and right of the middle point, does it have like the same value or not?
Yeah.
Okay. Let me think. I'll do that. C H.
Tell me about how many middle points you can find.
The middle point I can start with B from like if I start from 0 and J from So if I start from 0, so I will be run from 1. I still run from 1 until the length minus 2. I mean that is the whole middle point we can have, right? For example, like if this string like A B B A, so I mean we have a 2 middle point, right? B.
No, check every possible middle point. So A can be it can be a middle point, right? B, it can be a middle point, right? B, next B, right? One
yeah, but
middle point.
I don't calculate A because I know like we cannot expand to the left, so that's why I don't calculate here. Yeah, calculate them. I only calculate the some middle point which have a possible I can expand to the left or right, because A, you know, have a like in the border, so we only expand into the right. So it's, okay, let me think. Okay, if we have a B, you can expand into the left, and B you can expand to the right. Yeah, there's a B. Yeah, I for that one, you calculate palindrome. I think I'm okay. Like for the when we have a B B A, for example, you have a B, and then you expand for the left. You can see like, hey, A doesn't map with the B before, right? Or you can have a B B, and then from B B you expand into the left into the right.
Yeah.
I think like the time, if that's one, maybe the time complexity not ON square, because how we can keep that value, because anyway we need to
we can.
Okay, let me think about that. On, let me get on square. Okay, look like we travel through all the string and we start from like some middle point, and we can think like from that middle point how maximum we can go. Like for example, like we have a string. Let me because I don't have a very clear idea, so I will try to use the example and try to go. That is the what I'm thinking right now in this situation.
Okay, let's generate one middle point. So let's check it.
Okay, so for example, now I can have a C, right, middle point. So I don't care about that because C cannot expand. So I go to H.
Yeah.
I go to H. So have a like, I mean, I can travel from left and then I have a travel from right? I mean, I see have a hey, I have a C and H, maybe there's an equal, and then I don't travel, but have a corner K. Like how about right now we have a H, and we have a something like CCD like this, but actually you have a A and B right here. So wait, and B like what the example you give. So that means if okay, no, but no problem, right? Like that means if I have a of H,
yeah.
For example, I have a H B something and H B.
Yeah.
If I have a H anyway, if I'm start from the H in the middle right here, anyway I can sorry, A right here. Anyway, I can expand into the left and right maximum, right? But if I have a H B like this, I need to calculate one thing, like from here, I need to expand in the left, or I include one more, right? You see? Yeah. Because if I have a H, that problem is easy, right? Because anyway, if I don't expand from first H, so in the second H, anyway, it can expand, right? But if I have a H like this, if I don't include the second H, so that means I have a two way to expand. So that means from I and I, for example, I call I equal current H, right? I and I minus 1 and J and I plus 1, like how I can expand. Or I can have an I and I plus 1 like a group. So that means I will have a like I minus 1 and J will be plus 2, because I assume like so I plus 2, sorry. If you got my point. So that means I assume like I and I plus 1 will be a group. For example, like this, AHB, I can see like I minus 1, right? Like H, and so I will be H, I minus 1 also H, and A and B will be like, sorry, A and A will be like the next point I need to expand. But for H, so anyway, from the middle point, you also have a H, right? And then you
only one H.
So that means only one characters, and then 2 characters have the same, you can try bouquet to expand.
Yeah.
But if they have a more than 2, so you doesn't care. You can, I can expand anyway. They will be covered in the next position. So that means we have a first for loop. We go through all the character we think like we can expand. So that means from anyway, we can go from I into the end of the array, right? I equal to 0 into the end of the string, and then for every dash we will try to expand in the left and we try to expand in the right.
Yeah.
And then we can count like what in we expand to left and when we right, and then we can count like what is the maximum point we can expand.
Yeah. And so we are calculating along this final substring for every middle point.
Yeah. Did that make sense?
Yeah, it makes sense.
Could I stop recording?
Okay, let's go.
Yeah, let's go very quick. Okay.
Okay,
let me see. Have a like in also same method, but
okay, let's copy it.
Copy it. Have a S. And because string is not empty, okay, so I will for in I equal for like 1, I less than or equal 8 dot length minus 2, right? I will be plus.
Oh, yeah. Okay.
Right. I don't go from 1 because I know I cannot be it big. At least will be 1, so I don't care about like. Okay. So that means
I understand.
Yeah. Okay. So that means I have a math right now. Also I have a math. Have a start equal for 0 and also equal for 1, and I have a like string result equal for empty plus for 8 dot. Okay. I should copy then. Result. Okay. So now okay, so I will have a expand, right? So for example, like basically call expand like I minus 1 and we have an h I minus 1 and I plus 1, right? And I assume like it's expand something like that, my bad.
Okay.
And then I assume like this method I have already implemented. I will implement later. I flush through something like this, right? And I mentioned I flush through, right? And then I will have a like result, right? Result 1 equal for expand, and result 2 also equal for expand.
Okay. For result 2, you should check something.
Yeah. For in the method, I should check. I should check.
Okay.
Yeah. Okay. Result 2, but no, it's result. It doesn't make sense. I need to return for starting and ending point of the window, right? So let me return together.
Okay.
Yeah. Result 1, about like result 2, right? So if I have and first one I need to compare what is the result 1 and result 2 written. So I have a like compare last result equal. I compare for result 1 and result 2. I assume this method I have already implemented. Okay. And then now for result have a like the result is have the length of 2. So first the start and second the end length. So and then I will compare for the maximum. If we have a maximum, will be less than for result at 1 minus for result at 0, and then v plus 1. So then we will have a mass equal there, math equal for result at 1 minus for result at 0, and then plus 1. If I have a mass like this, I will update string. So we have I will have the start equal for result at 1 at 0, and will be equal for result at 1 will be plus 1, and then I will return for like maybe I return for result, right? So we can for h dot substring for like start, and then I have an end. I maybe doesn't need to have a like result like this, and right? Okay, and then I will implement It does make sense
Okay.
so far.
Okay.
I will implement the method expand. Okay, so private expand. So we have a return array. So we have a expand, and then we have a string age. Have any question before we move forward?
Yeah, you assign value results first one to n value, right? So why?
Yeah, to n. Yeah, because I have an n equal for last result plus one already.
Plus one. Oh, okay.
That means if I have a like string equal for 0, so that means start should be equal for 0 and n equal for 1. That means the n will be like the over equal for the size of the string we want to.
The size. Okay.
The last index plus for 1.
Okay.
So that means, yeah.
Okay.
Okay, so I have a string I and j, right?
You can continue. So.
Yeah. Okay. They have a like they go for 1. So how can do that? So if you have a like, we can check for the condition. If we have a like I and j, for example, if we have a y, I will be greater than equal for 0, right? And j will be less than equal for h dot length, right? Less than h dot length.
Yeah.
So that is what we can, that is the while loop we can go. So, and first one, we should check for like if h dot ks at I. First one, okay, first condition, like if I have a like I will be less than 0 or j will be greater than equal for h dot length. So mean we can return for like empty new integer. Sorry.
Okay, but the while loop can help you to do that. So maybe you don't need.
No, right? the reason I do that is because I care about the k a and a like this for b a and a, and then I want you to compare like if a and a have all the same value. If they doesn't have the same value, I can return, right? Because okay. I have a like okay, yeah, but that makes sense. But if I make you confused about that, sorry. Let me check one more condition here. In at the like you can see my. So I only expand for I to the I plus 2 if I have a like I plus 1 less than h dot length, and I will have a h dot ks at I equal for h dot ks at I plus 1. Right? Yeah. I only need to expand in that case. Maybe it doesn't need to expand, but in the case it's same, so I can expand. Okay, so now right now I doesn't need to check for that condition anymore. I plus 1 is j, and then I have a value like integer. Okay, right. Let's do that. How can do that? So for example, we have an I and j. If we have a h dot cat at I. Oh, sorry. We can add condition right here too.
Yeah.
And have a 8 dot.
It's cool.
At I equal for 8 dot. J, right? So I mean we have a like I minus and have a j will be plus, right?
Yeah.
Right, and then we will return for new integer of ij right here.
And okay.
Yeah, and then I will implement the compare method in compare. And we have like A and B. Okay. Okay. We have like result to the block right here. So I need to put result here outside. In that condition, so make sure they can compare. Result here equal for new integer at true. So and then I assign the result here for there.
Yeah.
Right.
That tab it one tab. You can use one tab, yeah, to make your code beautiful. So
yeah,
one.
Right. So okay, how I can compare for that? So for example, like I will for I mean I and J, right? For I mean if I have like I and 1 minus for A at 0 will be less than or equal, greater than or equal for B at 1 minus for B at 0. So mean have a more than, so I can return for A, and then or L I will return for B, right?
Yeah.
Right. And what else? What is the method I compare? Yeah, basically like that. Let me see if I have a code. For example, A, we have a like empty string. We doesn't need to care, right? Okay, because you say like from beginning we don't have empty strings. Okay, we can start with like C, B, B, A, and D, something like this. Or like we have a C, C, A, C. Okay, like something like this. I'm start with the CCAC first.
Okay.
Okay. So first one, I will have like, oh my God, I go down and then they don't see any code anymore. Okay. CAC. Okay. So I'm start for I equal for 1. I equal for 1. And I can see like, hey, I equal for 1, I at C right now. And then when I zoom into like, I will have a expand method. Expand from 0 to 2, right? Let me start maybe string and 0 to 2. Okay, what I got from the expand right now? Expand, so I will have a like C equals C, right? So mean I will increase for start and end. Okay, I can see my code have a bug.
Yeah.
And then I can
function.
In the expand function. So I should have a like I plus 1 and J minus 1, right? I plus 1 and J minus 1. But let's see if we do like that, whether we have any bug or not. If they have, or if they, in the case they only have a like no C like this. No, they only if I only have a CBC, if CBA or something, I'm start from B and I go to C, and then if I plus 1 limit 1, so that means I go back from the C, right? I want to, because I'm a little bit worried about like I plus 1 will be greater than J, but that kind of don't happen. Okay. So mean I will have a like CAC, and then I see like now, so now it will become like 0, 0. Sorry. I start from like I have a like 0 and I'm start for 1, and then I have a 0 and 2, and I think that's one, it doesn't equal. So that means the length will become 1 and 1, right? And then from expand from 0 to 2, I return 1 at 1, right? And then I compare for the C and A, I don't have a C equal. So that means expand right now, I return the result with 1 at 1, and I see the length of that one also equal for 1, right? And it doesn't greater than math, so I move forward, right? And then now I will be equal for 2. So I will have a like expand from H, and I have a like 1 and 2 right now, right? 1 and 2. So I feel like I have a 1 and 3, sorry, 1 and 3, and I have a C equals C, right? So that means I will move the expand from 0 to 4. But now 0 to 4 greater than out of the bound, because we have a condition to check that. So that means we have like 1 and 3. And then we have like length of this expand will be like 1 and 3. So that means the length will be 3 greater than math. So you have a start will be equal 1, and n will be equal 4. That means you have a start equal 1, and n right now will be equal 4, right? And then you move to, and then we end up the for loop. So we have a start equal 1 and n will be 4. So 0, 1, 2, 3. So that means we have a CAC is the result. Did that make sense so far?
Okay.
Yeah, right.
Yeah, I got it. So
okay.
The code, the code look good. So
okay.
I think it's enough. So your code is solid. So
okay, yeah.
Okay, but however, I will give you some recommend. So like Communication skills is very good, but however, you take too much time, to explain to me, and during the time when you explain to me why you coding, right? So why coding? So you can re-explain one more time. So it's reason why I tell you it's waste time. So because if you once more time, it takes too much time. In this case, okay, because you can solve this problem quickly. But however, in another case, maybe it's not too good. So
I understand. That means so we need to code faster then, right?
But however, everything went well. So
because I'm actually sometimes I also have an idea, but I try to explain, like I want to let the interviewer know what I'm thinking, what the evaluation in my mind, like how I can develop the thinking, and because I will try to balance that. For example, sometimes I know, like I think about some idea, and then I can try to explain shorter than, and then and during my coding I can explain more or something like that. Because I want to my thing, like I want to give them my whole idea, and then a little bit more detail, and then for sure, like this is take time.
Based on the best practice. So I think for the medium question, like this is medium question. So you should take at most 20 minutes to show and write test case or explain. So 20 minutes is okay. At most. Okay, but today it's good enough. It's good.
Okay, thanks so much. Thanks for your time.
Okay,
thank
you so much.
We can talk later.
Okay.
Thanks.